So my dear students, we know this water has so many properties, like it can exist in all these different stages like solid, liquid and gaseous, and all these stages are actually familiar for you, isn't it? So now we are going to change this liquid into solid. How can we do that? Yeah, the possible only one possible method is that we can place this water in a freezer so that we may get it as a solid. So let's do it. Yeah, so dear students, like you can see now that water has changed into solid. You can see this thing. Actually, it's too cold. Okay, so now let's discuss about some of the properties of the solid stage of water. So that is ice. Okay, so you can understand previously it was in a stage like all the molecules were having so much of spacing in between them, and when we place it inside a freezer, we know that that spacing decreased and the intermolecular force of attraction increased a lot, and it changed into solid. Okay, oh, what's happening actually? Yeah, now you can see this solid starts change into another state, isn't it? You can see, right? Yeah, even in my hand it is changing into liquid. Actually, I was talking about this ice, and at the same time it started changing into liquid. So how can I do that? Yeah, now it's changing. Actually, why it is so? When this ice piece was there in the freezer, it could stay like that for so many hours. For so many hours, it could be like that. But when we take it outside from the freezer, yeah, it started changing into the previous stage, or change into liquid. You can see it almost at within few minutes it will completely change into water. So there is no point in keeping this thing in my hand and saying about solid, because it's already changing into water. Okay, so now let's see why it's happening. When it was there in the freezer, yeah, when it was in the freezer, it could stay like that, like solid or ice for any long time. But when we take it outside to my hand in this kind of a room, now it started changing. So something happened to it. Why it's changing? Why it can't be like the solid some few more time? Why it's so? What's happening to this? Yeah, you may know the answer. Yeah, it cannot be like this solid for any more time in a room temperature like this. Okay, now let's see some more factors about why it is not able to be solid in a room temperature, or why it cannot be ice in a room temperature. Okay, now let's see it. So let me keep it somewhere, it's too cold. So dear students, actually what we could see, when that water was in a freezer, it changed into ice, and it can be in that form for any more time, even inside a freezer. But when we take that ice out from that in a room temperature, yeah, it starts changing into liquid form or into water. So actually some basic things are familiar for you. What is the reason behind that? Why it is not possible to be a solid in a room temperature, or to be ice in a room temperature? It is not possible. You know that if we keep that ice piece for few minutes in a room temperature, it will obviously change as liquid. You are familiar with that. Okay. So what's happening? Yeah, you know that, right? So the thing is that when we take that ice piece from that freezer into this room temperature, something changed. Yeah, what is that? Yeah, you know that. Yeah, the thing is that the temperature level in these two places are extremely different. Inside a freezer, the temperature level may be below 0 degrees Celsius. Obviously, in a freezer, the temperature will be below 0 degrees Celsius. So you can imagine how cold it will be. So the temperature level will be so cold. There will not be any kind of so much of heat energy in it. Okay. Then what about this room? Will it be again 0? You know that it cannot be 0 degrees Celsius. It will be, even in this kind of a climate. It's in Kerala, and we know that it will be around 28 or within 30 degrees Celsius. See the difference. Inside the freezer it was below 0, and in this room temperature it will be within 30 degrees Celsius. So what's happening? What is the reason? So how it can affect that state of this water? Why it is not possible for an ice to be in the same state in a room temperature? Yeah, when we carry that ice piece in our hand, actually that ice piece in contact with another thing, that is the atmosphere, the air around it, and this atmosphere will have its own temperature that is around within 30 degrees Celsius. Okay, so these molecules in the ice will absorb this heat energy from the atmosphere. Do you get it? Some of you may know about all these. Yeah, I know that. So whenever we keep that ice piece in a room temperature, it will absorb heat energy from where? It can absorb heat energy even from my hand also, right? Yeah, it can absorb heat energy from my hand. That's why we feel so cold when we carry that, because it's absorbing so much of heat energy from my hand. As a result of that, I may feel so cold. That is the reason. So that ice piece will get heat energy from my hands and from my body, and also from the atmosphere. So by absorbing all these heat energy, what will be happening inside? Yeah, you know that. Initially this ice piece will be in a stage like this. All the molecules will be tightly packed. They may be able to only vibrate. But when they get sufficient heat energy, they will be able to move apart. They can block the intermolecular force of attraction. Okay, so remember the amount of heat energy needed for this thing, for this increasing the separation and blocking this intermolecular force of attraction. For the ice piece, when we keep it in the room temperature, they will be getting the heat energy from the atmosphere itself. Do you get the point? Okay, so in the last class we learned actually about this thing, and this can be called as the change of state of a body. Change in state of a body. Is that okay? Is it clear for you? Okay, so is it possible for you to just define what is this thing? Yeah, it is the change of a substance from, what is it, solid state to liquid state. The change from solid state to liquid state. What can it be called? What is it? Yeah, that is called as melting. That is called as melting. So you can easily just define what is melting. Melting is the change from solid state to liquid state. Okay, fine. I hope you can understand and follow all these things. Okay, very fine. Now there is actually one more important point. Okay, and that is a bit more complicated, but I will try to explain it. Anyway, you try to understand. When these molecules are getting energy, you know that, listen carefully, it's very important thing. When these molecules are getting sufficient energy by absorbing the heat from the surroundings or the possible things near to it, okay, anyway it will absorb heat energy, and as a result of which they will gain energy and they will increase their kinetic energy. Is that so? Usually the molecules will try to increase their kinetic energy by increasing the separation and all those. They will try to move apart. They will randomly move, as a result of which their kinetic energy will increase. Okay, as a result their temperature level will also increase. Okay, so if we keep an ice piece and if we check the temperature, when melting happens, it change from this minus degree Celsius into gradually into 0 degrees Celsius when we keep in a room temperature. But the magical phenomena that will happen over there is that when this ice piece started melting, when it starts melting, then the temperature of this ice will stuck over there. Simply like that. The temperature when it reaches 0 degrees Celsius, actually the ice will start to melt only when it reaches 0 degrees Celsius. Remember that it was initially at some minus degrees Celsius. Okay, when it gets sufficient heat energy from the surroundings, what will happen? Yeah, its temperature will increase gradually from minus to up to 0 gradually. So I told you, when it reaches this 0 degrees Celsius, yeah, the temperature will not vary again, will not increase again. It will stuck over there. Simply think like that. Yeah, then why it is so? Yeah, just because of the reason is that when these molecules are getting sufficient energy, sufficient kinetic energy, then they will stop all this kind of vigorous motion and everything. Then they will start to increase their separation. Otherwise, we can say they will increase their potential energy. You can also say like that. Okay, anyway, just remember, when they all get sufficient energy, they will then try to increase the separation only. Okay, and at this point, this ice will start to change as water. Okay, I know that this portion, like this small facts that I'm explaining, may be a bit more difficult for you, but detailed thing that you will learn in your 10th standard, this change in state and related all these facts you will learn in 10th. Okay, and for you children, you need to understand the facts that you need to learn in 10th standard, and if you try to understand that facts in your 8th standard, it will not be possible. Do you know? Because in each stages, in your growing age, like in your this teenage age, in each year your intelligence level will be drastically increasing. Okay, so even within 2 or 3 years your intelligence will increase in such a level. Okay, so but when you reach in 10th, you will be able to easily understand some more difficult things about all this. But one thing you need to understand, the thing is that when all these molecules are getting sufficient energy, sufficient kinetic energy by absorbing the heat from the possible surroundings, then what will happen? When they will try to increase only the separation, not the kinetic energy. Okay, as a result of which, if we check the temperature, when it starts changing into water, or when the change in state happens, the temperature will not rise. Or you easily remember one thing at least, is that whenever there is a change in state or change in phase happens, the temperature will not increase. It will reach at a certain point and it will remain there. That is the thing. You get it? I will give you an example. And if it is for ice piece, you know that the change in state will start only when it reaches 0 degrees Celsius. From some minus degrees Celsius, and when it gets sufficient heat energy, it will increase up to 0 degrees Celsius, and up 0 degrees Celsius, this ice will start melting. And you could see that when I kept that ice piece on my hand, it started melting. So much of water coming from it started changing into. So that simply means the temperature level of that ice piece at that instant was 0 degrees Celsius. Only at 0 degrees Celsius it will change as water. Do you get it? Okay. So it is not only for this process, for any kind of change in state, it will be occurring at a constant temperature. Remember that. You just simply understand this fact. Okay, no need of worrying about any more detailed things, because I told you detailed things you will learn in your higher classes. Okay, don't worry about all this. The one thing you need to understand is that any kind of change in phase or change in state will happen at a constant temperature. Otherwise, we can say it in other words, at a stage of this change in state or change in phase, temperature will remain constant. The temperature will remain constant. And if it is for this melting, we were actually discussing about melting. In the case of melting, the constant temperature at which the solid changes into liquid. We can call it as like that, right? The constant temperature, you get to know that there will be a constant temperature, and the constant temperature at which the solid changes into liquid can be called as, it can be called as one word, that is it is called as melting point. Actually, it is easy to remember. Okay, if it is melting, it will be melting point. Okay, so whenever you hear the melting point, you need to understand that is the constant temperature at which this state change in phase will occur. Do you get it? Okay. I hope that you can understand all these facts, because this is very simple fact, and this is one of the very simple portions that you can have in your 8th standard. So take it very easily, because actually these things you have already learned in your previous classes, isn't it? Yeah, some of the basic things you have learned, but in this 8th standard we are trying to understand the things in a kind of deeper level. Okay. So things will get into more and more deeper when we go into higher classes. Okay. So I told you your intelligence is drastically increasing. Remember that. Okay. As you are in a teenage. Fine. So this is called as melting point. So we simply learned two important definitions. First of all, it was of melting. So can you tell me what is melting? Yeah, the change from solid state to liquid state at a constant temperature is called as melting. So remember, you need to add one more thing. What is that? At a constant temperature. Okay. And one more is that in all this definition, you need to mention one more thing. Actually, that is easy. By absorbing heat or rejecting heat. In this case, it is very easy to understand. For melting, it needs so much amount of heat energy, so the body will be absorbing heat. Remember that. So you need to mention that also in it. Okay, so how can we define? You need to add all these things in it. Okay, so say with me, melting is the change from solid state to liquid state by absorbing heat energy. One more thing, at a constant temperature is called as melting. See, even if it is a very simple definition, you need to understand one thing. You should not skip any of these important keywords in it. What are the things? The change from solid state to liquid state. That is one of the important thing in it. Second thing, by absorbing heat energy. You should not write it as rejecting heat energy. It will be absorbing heat energy. And the third thing, at a constant temperature. These are the main things that must be there in your answer purpose when you go for this kind of answers for all these questions. Remember that. Easy. Yeah. That is the way in which you need to learn physics actually. Okay. Don't ever try to by heart. Many times I told you, don't ever try to by heart any of these things. You need to understand the facts, and you need to understand which are the basic points in it. Okay. So if you understand the basic points, you will be able to easily define it. Try to say it once again. All of you need to say. Okay, I told you I can hear whatever you are saying. Okay, remember. Yeah, come on. The change from solid state to liquid state, yeah, by absorbing heat energy at a constant temperature is called as melting. So there was one more. What was that? Easy. It was melting point. That definition is actually already there in it. The constant temperature at which a solid changes into liquid is called as melting point. Actually, all these are very easy things, right? You can easily grasp all these things. I know that. Fine. Then, dear students, actually you may be thinking like some of the basic things of all these things you might have learned. So what is the importance of learning all these things again? I know that you just thought about all these. So the importance is that in this classroom actually we need to think all these concepts in a kind of molecular model. You remember what is molecular model? Yeah, the things like the separation, the intermolecular force of attraction and all those things. So you must be able to explain this melting in terms of molecular model. Will you able to do that? Yeah, just try it. Yeah, you can try it. In the case of this melting, you can understand all these molecules are getting energy from the kind of heat that they absorb. In the case of the previous case, in the case of that solid, it was getting heat from my body and the surroundings as well. So anyway, it was getting heat energy, and when the molecules get heat energy, sufficient energy, they will try to increase their kinetic energy. Okay, though, so they will increase the separation in between them. They can they can break the intermolecular force of attraction. They will increase their kinetic energy. Okay, but that process will be only up to that melting point. That is the thing you need to understand. The detailed thing is that you know that there will be a constant temperature. That means in the case of that ice piece, it was initially at a minus degree Celsius. Okay, so it started getting sufficient energy. That means the molecule starts moving, randomly moving by getting kinetic energy and all those things. And when it reaches the 0 degree Celsius or its melting point, what's happening there? Yeah, the thing is that until then they were utilizing all the energy for increasing the kinetic energy, for moving and increasing the energy. But one of the things that is going to happen there is that, remember, when it reaches 0 degree Celsius, that means when it starts melting, yeah, the increase in kinetic energy will stop there. Okay, and then all the energy that it will get will be utilizing for increasing the separation in between the molecules. That means simply for the phase change. And that is the reason why during the phase change there will not be any increase in temperature. Remember that. So dear students, the important thing you need to remember in this section is that in the case of melting, whenever there is the phase change, yeah, when it reaches the melting point, the energy, total energy that it absorbs will be utilized for the increase in separation between the molecules, or we can say that for increasing the potential energy, not for increasing kinetic energy. So you may get different questions like during phase change whether there will be any increase in kinetic energy. What will be your answer? Yeah, your answer must be that there will not be any increase in kinetic energy during phase change. Remember that. During phase change, all the energy will be utilized for increasing the potential energy. That's it. Okay, so this is the thing actually you need to understand in detail. Okay, so I hope you can understand. So during this melting, all the energy will be utilized for increasing the separation. That means the process of phase change or change in state is happening, and all the energy will be utilized for that, not for increasing kinetic energy. Only when there is kinetic energy, there will be a kind of rise in temperature will be there. Only when there is an increase in kinetic energy. So far there is no increase in kinetic energy, so the temperature will remain constant. That is the reason. Okay, so one of the main important thing is that during any kind of this phase change, there will not be any rise in temperature. It will be occurring in a constant temperature. That simply means there is no change in kinetic energy. Okay, do you get it? Yeah, you need to remember that. That is one of the important thing and the new concept that you are learning. Once again, now let's see, we had already seen when we kept that water in the freezer, what happened? Within few hours that water completely changed as ice, doesn't it? Yeah, that's it. So it's also a change in state, right? You know about it. That means liquid change as solid. It was also at a constant temperature. So can you define what is that? What is it called actually? Yeah, you know that is called as freezing. Can you define that? Yeah, try to say that. If you can define melting, you will be able to define this thing as well. Yeah, what is freezing? Try to say that. The change from liquid to solid. The change from liquid to solid. Yeah, next thing I want to hear from you. By absorbing heat or liberating heat. Yeah, that's it. Some of you may make mistakes with that. Remember that whenever a substance is in liquid state, it will be having much more energy than when it is in solid state. And think about if it is in gaseous state, it will be having much more energy than these two stages. Okay, so when a substance is in liquid state and it want to change a solid, it need to liberate all the energy it had. Okay, so in a liquid state it will be having so much energy, and if it want to change as a solid, it will liberate all the energy. So you need to remember, when a liquid change a solid, it will liberate heat energy, not absorbing heat energy. Remember that. Okay, so how can you define this? The change from liquid to solid by liberating heat energy at a constant temperature is called as freezing. Okay, and here you know that there will be a constant temperature again. What is that? That constant temperature can be called as freezing point. Easily defined, you can easily define this. The constant temperature at which a liquid changes solid can be called as the freezing point. And here, one of the important things you need to remember is that the freezing point and the melting point of any substance will be same. For water, it will be 0 degrees Celsius. The melting point will be 0, and the freezing point will also be 0. Okay, so for any substance, the freezing point and the melting point will be same. Don't forget that. Okay, fine.